All right, let's do this. When I left off, where the fuck was I? Oh yeah, I made a whole bunch of notes. Whole bunch of notes here, or I made. Okay. Uh. Okay, so when I left off, I was deliberating about how we have a. How are we going to convert stop orders on the server? Because they need to go from the execution, and they need to go back into the software queue. Now, I don't want to put them immediately back in the software queue because that's kind of like cheating, I guess. There might have been a hardware event that was about to be converted into the software queue that would have taken priority. And the answer to this and another question I had elsewhere is we need a circular buffer, and I'm gonna do that, but also I am also going to add a secondary parameter to the what is it? The free list. The free list. Where did I put it? Right here. I had this. This is the only note I had, but should be set. Should say free list. Should have an option to reserve special types, and we're gonna need, I believe, one, two, maybe like four special types. So basically, it's going to be like special IDs that can't be reserved. And to make sure we can't reserve them, we're going to modify the free list. So let's go ahead and dive into that before we do any other more interesting stuff. So we're going to have to kind of rewind a bit. Vi fl.c, oops, vi source fl, source, very funny. Vi source fl.c, and in a separate one, okay, I'm just going to layer this on top, I don't care. Here we go. Vi include fl.h. So instead of just fl8, we're going to have a, what are the, uint32 type, reserved, reserved IDs. Max reserved ID. So let me make that clear, and we shall put that. It's yeah. So uint32 type max reserved ID. Honestly, this probably could be a uint8, just because it's not. We're not gonna have like more than a handful of these. In fact, we could probably put these into a single, some compression. These could be a single char. Okay. Okay. So what are we gonna do with this? Basically, max reserved ID. Values below this can never be assigned. And you might think that this does leave like an extra type size. If you multiply these two, that's how much space we're basically going to be giving up. We're going to have a small gap in this free list that's never going to be filled because of those special IDs, but I think we're going to have so many that it doesn't really matter. So let's see what we can do this. So FL allocate size of FL. That's fine. Data. Honestly, we could do something like this. So if we have, oh god, this is actually if we can't assign 0, then we need to subtract 1. So this is max reserved ID plus 1, or actually reserved IDs, lowest n values can never be assigned. Yeah, so we'll call it reserved IDs. That makes the math a little bit easier. So if we have 3 reserved IDs, we just subtract that, and you'll see how else this makes it easier later. Yeah, okay. And then stack, I'll come back to these allocations. We might, it might still be a good idea to just have these, wait a minute. If we want to do 32 bits, like we have a, if we do, if type size is 4, so it's 4 bytes, and we do an odd number of max reserved reserved IDs, that's actually not going to align this whole data structure to 8 bytes, which is not good. We want it to align to 8 bytes. So in that case, maybe we don't do this. Maybe we just take the loss, but it's going to be a fixed loss of a couple bytes maybe. So that's fine. All right, we don't do that there. The more important one is we just don't push it into the stack, and then we keep the stack a little bit smaller. So the stack, represents open spots. So if we actually start at reserved IDs, so not 0. But if you reserve 1 ID, then you can't use 0. So we start at 1. If you reserve 2 IDs, you can't start at 1 or 0, so you start at 2, hence why we have this. And then we just stack I is equal to I. That actually works. Because then we just do, instead of 0, wait a minute. Let's check some of the easier methods. If FLSP is equal to FL capacity, this is a really troubling one, but most of these are, yeah, okay. FL release is fine, FL free is fine. It's really just FL insert that could have problems. So let's think about this. If FLSP is equal to 0, I don't think this is what we need. I think it's actually, what we had was basically if we had 0 reserved IDs, so we're just going to do this, reserved IDs. So if we're at, so we're probably going to set it to, oh no, we'll keep it initial capacity, but we'll just block it from, doing this. Okay, let's see what else. Quick check. If FL capacity 1 is equal to 0, this is this basically means bit overflow does not fit in 32 bits anymore. Okay. Doubling capacity is fine. We're just gonna copy over. Oh wait, this is the stack. The stack is the IDs. Well, we can save like 1 nanosecond of time by doing this. There we go. And then we just, it doesn't really matter what the ones below that are, so that's fine. So I is equal to I. Then we do free of FL stack, free of double stack. That's fine. Copy the entire data over. Data. Wait, there's FL and there's data. Wait a minute. What the fuck am I looking at? I realized. Oh right. Okay. So this is where we store it. So it also means that the first, reserved. Yeah. So we lose a bit of space here, but that's okay. I think this. Where is it? What did we return? Yeah. This whole math here is. Wait. Yeah, this is different. This is not, this goes through the individual index. If FL, let's throw in a different idea. Or ID is less than FL. Wait a minute. If FL is at capacity, this is like. this FL is at capacity is basically when we're trying to, when we basically initialize the free list and then we immediately try to release for some reason, which is just going to break. Or if FL is less than reserved IDs. In these cases, what do we want to do? Is it less than or equal to? Can we do 0? If we have one reserved ID, yes, that one reserved ID is 0, and accessing 1 is fine. So it's a less than case. All right, that was actually pretty easy. It might break a few tests, but let's find out. Make test. Okay, cool. That's an easy one. We'll just do this. Reserved IDs. Yeah, and we'll just copy that. And this can be different per free list. Like, there's going to be a free list for response IDs, so not from the server client to the server, but from the server to the client. So that one, I can't think of any reserved IDs right now, but this one will definitely need a few. And this is default 0, of course. And FL FL reserved IDs is equal to reserved IDs. And that's pretty good. And this is of course going to fail the test because make test. Of course, actually probably going to commit this. Client 0 does not need to be committed just yet, but we'll do make test. This should fail. Did I? What? What are you on about? Where is this? Who has this open? Where's client 0 open? Client 0 is not open anywhere. Hold on. Storm strategy. UN64 type. Alright. Maybe. Okay. Let's go back. Okay, make test. Okay. Okay, that's good. VI test FL. And then we're gonna need to 11. We'll just throw in 0. Cool. And then that should work just fine. Oh, what the hell? Why does make test do all that? The hell? Oh, because we're running the scheduler test. All right. Are we not running the? I don't think we're running the PQ test though. Yeah, we're not, or FL rather. Let's see if this works. It shouldn't be a problem. It's just a little guard. Okay, cool. It does reduce capacity by like 4, but it's fine. Okay. Now, just save that. Test FL. I'm not gonna commit main. It doesn't really matter. Source FL and include FL. Git commit. Allows for reserved values in the free list, useful for special packet IDs signifying server event, special server events. It's going to be probably 4 of them. Now, we're going to do is actually let's pull this up. We're actually going to have a new one. We're going to do test CB. Did I need that? Maybe. Okay, I'm gonna read this a bit carefully before I just close it. This is main. We're gonna step away from this for a second. This is FL. I think we're good on FL. Okay, so it's just these two. All right. This looks like an important note. Don't schedule for server exec if there's someone ahead of you in the server queue. This is actually really important, but I'm gonna save it for later. This is just make test, and this is FL. Cool. Okay, nice. We have 2 little windows open. I'm just gonna. Okay, why did you do that? First thing we want is vi makefile. We're gonna throw in cb.o, and then we're gonna do touch source cb.c and touch include cb.h. And let's open both of those up at the same time. cb.h cb.c and vi source include cb.h. This is literally just going to be a free list, or not free list, circular buffer, which we basically have implemented here. No, not here. In the bullshit in the bullshit file. Actually, I'm just gonna copy it from bullshit into I'm actually gonna copy all of bullshit to wherever we need it to be. So source circular buffer, copy include bullshit to include circular buffer, and then copy test bullshit into test circular buffer dot h. I think that should do it. Okay. Vi test main, and we'll do include circular buffer. All right, make test, see what happens. Okay, cool. Test CB, of course not. We don't need it. Let's break this down. So let's start with CB and include, and then we'll get the test running. So CB, this is just a circular buffer. Another question is, do we want blob store to use the circular buffer for the metadata? I'm gonna lean no. Actually. Alright, this is just a circular buffer. Actually, shit, I think we need one more special packet type, so it might be 5 actually, but we'll see. Do we want to commit to a certain size, or do we want it to be general? Because otherwise, if we make it general, we need to do something like who has a fair? Yeah, we gotta do something like this if we want to do that. Let me think about this. It's the circular buffer for both cases that I'm thinking of is gonna be it's gonna be in 32, or probably like 25 bits, but in 32 should be fine. Got that in 2 hours. Let's see. Oh, and another thing. I'm so fucking tired of all these in64s and whatever, so we're gonna do include call it types.h, and we'll do, why do h files not need to be compiled? Seems like magic, actually. Oh, source files. Alright, whatever. CUINT 64 shorthand. Oops. I want to call it U64. U64 sounds fine. What do we do? Type def or something? So it's gonna look like type. Is it? Do we want type def or the macro? I have no idea. Type def. Include std int. That is included twice here, just to be sure. .h std int type def struct is renamed to BS, so uint64 type becomes u64. Let's do 32 and 8. I haven't seen a 16, I don't think, so we'll just do that. So we can just start using this immediately because I'm getting annoyed at this. Types, is it types? Yeah, types. Okay, include types. Get rid of std int. All right, let's get started. So we'll need a MD start, MD end. Why do we need initial metadata index? There's like a good reason for this, but I forget. Whatever. We'll just rewrite basically the whole thing as CB. Every BS instance is just gonna be replaced with CB. UN16. Oh, there's our U16 right there. Good. The U16 metadata capacity. This is going to be just capacity. CB is equal to malloc size of CB, and CB is specifically this whole thing. Not std int, to hell with that. Include, we're lazy. We do types.h. MD start, we do U16. This is the start, U16, U16 end. MD capacity, yep. 1, 2, 3. Metadata, yes, maybe. This is going to be U32. Star. Wait, how? Wait a minute. How are we doing a? Wait. Wait, we have a BSM star, but we have multiple capacities. How are we using that thing? Metadata, yeah, 930, here. Oh, we do this thing, okay. And then, and then we do dot refs. I wonder if that's better or worse than using like a BSM star thing. I'm leaning, I mean, this is an array of pointers. Wait, why do we need an array of pointers? We just need an array of that. I don't think we need all that complexity. All right, so that's that. Okay, PS capacity is equal to that. Store capacity, there's no such thing. MD capacity, we're just gonna do capacity, or wait, BS. Everywhere BS appears, just do CB. I know I didn't need to do all this, but it's whatever. And here we go. This is faster than looking up the actual command for it. Trust me. Okay. And also, everywhere BS appears, we can just do CB. Okay, cool. Okay, we have start end capacity, which is capacity. Initial metadata index is interesting. I mean, really, what are we doing here? what are we doing here? This is max value. That's all we need. We don't need metadata, so literally just a CB. Okay. We don't even need IDs for this thing. We just need a push, and we need a pop, or Q. It's Q on Q actually. Circular buffer. Okay, so we'll do U32 CB. Reserve is like push, so Q has a circular buffer, and we're just gonna take some U32. I don't know. Fucking wait, what are we gonna return here? We don't need to return anything. U32. Maybe I should call him like 32 starts with a T, and then 16 starts with an S, and then 8 starts with an E, and then 64 also starts with an S. Damn it. Alright, whatever. Never mind. U32 fucking, I don't know, value, doesn't really matter. And then we're probably gonna take some of these validations, and I don't know, I don't care. We're gonna take some of these validations and just copy them into this circular buffer. Double the capacity. Wait, why don't we not doubling the capacity? Oh, because there's no clean way to double the metadata capacity. That is there is no clean way to double the metadata capacity because people using. Oh yeah, no, this is. We definitely don't want to make a circular buffer and then use it in the bullshit in the blob store, because the metadata is not quite a circular buffer. It's like a special circular buffer that's managed kind of differently. Okay. But if start is equal to end, we are at capacity. The main thing we need to do is we can do, if we have something like this is like 0, then we have end, and then right after we have start. So this is a bit confusing, but if end and start are equal, it actually means the last element is right behind start. So if end and start, and then we have so it really goes like 1, 2, 3, 4, and then back around 5, 6, etc. So if we have something that looks like this, what we can do is we can start from start. We can double the capacity and then just walk through it like this, and then like this, and then just insert everything, and then reset start and end to easier ways, which is actually what I hoped to do here, but it got so weird because the position of the metadata is actually very important, so that was just not a good idea. But we can double just fine here. We will have to write some custom. Will we? Oh wait, no. We actually have code pretty similar for this, and it's going to be even easier if we're just going to assume that we're going to use if we're going to be storing U32s. Where did I put it? Mem copy. We actually could do 2 mem copies, believe it or not. I'm just gonna give myself the format for that. So we're just gonna do U32 star doubled is equal to let's not call it metadata, just call it buffer. That's stupid word for it. Store capacity void store. Yeah, these are kind of similar in nature, except we're gonna commit to a type. And this is obviously going to be CB. We're going to have a CB init, CB init, CB init, capacity, CB free, CB, void, CB Q. Or I guess we could do like a boolean, like did it get in or not, CB U32 value. Alright, and then we're going to do DQ, or this one actually does need to be a U32, and then we're not going to take a parameter, we're just going to, or we could DQ multiple of them, couldn't we? No, not a good idea. DQ, deck. Should we just call it push and pop? Yeah, we'll call it push and pop. Although that implies stack. Yeah, fuck it. Okay, Q and DQ. This makes it clear that what we're dealing with here. Alright, get does not exist, sorry. Alright, U32 doubled array is going to be... Oh, we completely forgot the oh no. Yeah, we completely forgot the malloc. Where did that go? What do we call it? CB buffer is equal to malloc CB capacity times, actually no need to deref right there, capacity times size of U32, and there we have it. Okay, buffer hard-coded to UINT U32. MD star is unmetadata star, fuck off. Alright, CP unit, CPQ. There we go. U32 double is equal to this whole thing, except bigger. 2 times CP capacity. Okay. So that's the doubled array, and then we just do 2 mem copies, one for start to the end, and then one to start to capacity, and then one from 0 to end. So let's see how we're gonna do this. Let's see. We want to copy into 0. What do we want to do here? No, this is more complicated than it needs to be. This I better just write it myself. Okay, mem copy. Since doubled points to the start of doubled, we'll just do this. Doubled, and then we'll do. We're gonna copy from the address of CB buffer at CB start. CB start. Okay. CB start. Okay, so that gets that address, and then we're gonna. How much are we gonna copy? Let's say we have a capacity of 8, and then start is at 8. No, that's impossible. I think it's as simple as this. Capacity, so current capacity, not yet doubled, minus CB start. There. And that should copy everything from start to the end into copied. And then we do one more, which is going to be doubled. If we copied one thing into memory here, then we're going to want to start at 1 after, so we'll do CB capacity minus CB start, so that's where we copy into, and then we're going to copy from 0. And how much are we going to copy? Oh, wait. Oh, he almost got me there too. Times size of U32, which is 4, but just it's good to be explicit. Now, doubled. This is a U32, so I think this will get us the right address. We don't have to do any math here. But we're going to copy from, again, it's a U32, so we don't need to worry about that too much. But we're going to do U32 at, from 0, which I believe is the same as just doing this. And then we're going to copy, if end is at 0, we copy nothing, because start has to be at 0 in this case. If end is at 1, then we copy 1, which is just going to be like that 0 array. So we're going to do CB end times size of U32. All right, you see how this is kind of it's kind of like a it kind of mirrors each other. Copy start to capacity copy 0 to end. All right, so cool, and that'll keep it arranged, and then all we need to do is free the initial buffer, and then reassign it to that new one with all the copies. Doubled, and then we do cb start is equal to 0, or yes, because we specifically rearrange it to be like that. End is going to be the new capacity, which we can no, it's going to be the old capacity, because if it were to reach the capacity, it would have looped back around to 0, which is how we get into this situation. So end is equal to capacity. So now we can keep going past our previous bounds. And then last thing, capacity, there, just double it. And then that's buffer start and capacity. That looks pretty good. Okay, so this is a queue. If we do want a queue, normally all we do is CB. Actually, this should have good code for this. MD end. It's not just plus plus. It is going to be specifically this. It's this value. End is equal to BS end plus 1 mod BS capacity. Oh, sorry, CP and CB. All right, cool. Okay, and then that's the end value, but we actually do need to store it. So CB buffer end, current end is equal to value, and that's good. Oh, we can actually we can do that that completely out of capacity check here too. Where is it? Oh, okay, it's just this. Let's see if we even can double. So if CB capacity 1 is equal to 0, you're fucked. Cannot double completely out of circular buffer space. Cannot. Wait, is my mic on? I feel like it's been off this whole time. Oh my god. There we go. Whoops. Silly DJI. Cannot even double. Okay. Looks good. That's a little. Oh wait, we do need to return here. And return. And now we need a U32 CBDQ. Yeah, I like that one better. DQ deck. We'll deck it. And all we need to do is alright, so we have a equivalent for this. We don't need that anymore. Get is just there's no way we can wait. The only scenario is if CB. Oh my god, we need even. Do we need a reserved value for this? I don't fucking know. Maybe we can return 0. It's fine. If CB start is equal to initial start index, and then if it's there and end is equal to 0, I don't really think that one's necessary. So if this is the case, we'll just do return 0. Else return, not return yet, but we can do start also has to do this whole thing. So we'll do that, start and start, but we'll do that after we U32 result is equal to CB buffer, CB start, and then we double it, and then we return result. Pretty simple. This one cannot overflow us because we're kind of draining it. And I think that's all we need. And then we do free buffer and free itself. Cool. And it's not BS free, it's CB free. Cool. This one's a lot simpler. Of course. do we need string? This is for the memcopy, this is for the print, and this is for the malloc. Yeah, so this is all good. I don't think we need sdlib here, do we? And we do need to do this. C, C, and B, B, B. Okay. All right. Let's write a test for this. This one can be, again, copied from... let's see if it works. Make test. Right. 12 has... okay. Try again. Pretend I didn't see that. Cool. Let's actually write the test. This does not need to be that complicated. This is 60 lines. Test CB. We could just put it all here. What do we even need here? I mean, these are good tests, don't get me wrong, but oh wait, we need an initial capacity, don't we? Right. I don't know, A192. Wait, this one, what do we need this for? This is like, yeah, A192 should be fine. Or, well, 1024, why not? Because some of these are going to be pretty small, actually. Oh, in which case, that actually makes a pretty good argument for having a buffer. Maybe. I don't know, whatever. Maybe even this. I don't know. No, we're going to have many clients, so we'll need it to be doubleable. Let's get rid of that capacity, by the way. We'll just do initial capacity. This makes it even simpler, I think. All right, here we go. No initial capacity for you. Look at that. 63 lines. And, okay, let's try the test. We can initialize it. First store, that's not going to happen. Or actually, we can do this. Let's try this. CB. And then we'll do CB is equal to CB init. And we can do CB, U32 buffer. First buffer is equal to CP buffer, and we'll just fill this thing up. This is a Q is a void, so we can do CBQ, CBQ, CB value. You want a value? 1, 2, 3, 4. Then we'll do assert. We can do a few assertions. CB start is equal to 0, and the end should still be N should be 1 actually. And okay, and we'll do. It shouldn't. The buffer shouldn't change if we do this. So first buffer. Okay, and I don't even know why we assert so much for a single reserve. Oh, because there's 2 of them. Oh, also don't forget CB free, CB. All right, so we have this whole thing basically done. Overflow test. This one's pretty easy. All we need to do is copy that for loop. This doesn't return IDs or anything, so we don't need to worry about that. We'll just do this. Let's do this 1022 2 times, and then we'll do. It's not gonna be. We'll do CB Q. We'll do CB. I don't know. I'll make this one stand out really. There we go. Alright, so we'll queue those up, and then we can do this similar assertion. Except n should be, what is it, 1023? Or maybe even 0. I think it should be 0. Let's try this. Yeah, it should be 0 because there's no. There's going to be 1023 objects in it. But we can put it 1024, so let's put one more in. This shouldn't do anything. Make test. Nice. CB16, what's up with that? Capacity is, oh, yeah. There you go. Go ahead. Whoa. Oh, yeah, because I know why. That's why. Oh, damn, we already had that. Try again. Cool, only a few. Oh. Redefinition of, what are you talking about? This is not, oh, yeah, okay. How's that? Okay, initial capacity, right, CB, there, and then here 2, CB, okay, I think I'll close them nowhere. No, I don't. Okay, we have a assertion failure, which is not the worst thing in the world, but you know, it tells us we're figuring something out. How is start not 0? What else would it be? Oh, right. Right. There's a little catch there. Actually, do we even? Can this just be 0? No, maybe. No, because then we hit this thing. Oh, okay, hold on. If CB start is equal to what is that fucking number? Initial start index, then usually this is the only case where queuing changes start, kind of starts it up. One specifically. Wait. That's it. That's all we need to do. Because if we hit this, actually, we can even skip that check. I think they should work. So this is like a special case that, you know, these are completely different. And then n is set to 1, then we do this, then we increment. There. So 0 is written to this, and then we increment 0. Kind of a little trickery there, but you know. Actually, wait. I mean, n is already 0. Just do that. Bit of a trick. Let's try this again. Okay, well none of the assertions fail. Overflow though, end is zero. So if you do this one more time, you shall see that what's going to happen. It's going to double. So actually, start. You know what? No. Let's try dequeuing a bit, and then we'll fill it up. So we'll do CB deq CB. We'll check. This should be that 5,000, 50,000 number. So U32 get is equal to that, and then assert get is equal to 5,000, and then we can do a few assertions right here. This should move start upwards to 1. And we're still in the same buffer. But then if we queue up one more time, both of these should be set to 1. We're still in the same buffer, but if we queue up one more time, just throwing 0, throwing 0, just keep things interesting. Then it should double in size. And these should be reset to 0, and n should be, I believe, initial CB init. Fuck it. Okay, and then yeah, I think that should be what I need. Let's see it. Okay, cool. Maybe +1, because if we have an initial capacity of 8, maybe. What is it? This is line. This one's line 46, but this one's something else. Wait. Line 46, right? But then if I... Wait, what? What if I just turn this one off? The fuck? Is this the problem? What is going on? Is this the problem? Yes. Really? So if I do this, it's all good? Okay, so you admit that CB free doesn't work. Why? It's just buffer. What's wrong with buffer? You got a problem with buffer, buddy? You got a problem with me freeing buffer? All right, fine. Let's not free CB then. What do you got? What do you got for me? Okay, that's fine. Wait. So let's start calling it again. Honestly, just get rid of the rest of it. It doesn't really need it. Oops. Actually, that's easier to replace. Try that again. Whatever, dude. Very funny. Okay, still got that error. So, is this the problem? Free CB buffer? Yes. Why? Why can't we free CB buffer? We free here, then we set it to doubled. And this is... What the fuck? Wait. Whoops. Don't mind me. Nice. It's a silly little typo there. Okay, cool. CB works. Let's go ahead and include, or actually git add include types. Git commit got tired of typing uint64 type. Okay, git status git add include CB, git add source CB, git add test CB, git commit Wait, are we even calling it from the main source file? Yes. Added circular buffer. Method beater has 7. I'm not showing up late this time. A little bit more time, maybe. But the only thing I want to do is kind of reorganize, reorganize some of the types. Okay, what else do we need to do? Oh, this won't pass. Hold on. Git add makefile, git commit amend, git status. Cool. Git log p. So this should change makefile. Yep. Okay. Git push. Okay. Client 0 and test main. Test main doesn't really matter. Let's go ahead and actually wire this up in source main. Now this thing's a mess. It is not going to compile, but we can actually do a few things. If type is equal to boot type. No, this is completely wrong. This is completely off. And first off, I think I'm going to switch to only 2 type bits, because we only need 2. We only need 4. We need 4 types, and this is what they are going to be. If type is equal to, call it server event, or server type, something else. Oh, else if type is equal to client in type, client out type, and the other one is the recurring checker, I believe. Yeah, that keeps it. I think we already have this type. I called it type 7, but slow repeat type. Okay. We don't need boot. We're just going to keep all the computers on at all times, but they might not be connected. But you'll see what I want to do here. Slow checker. Yeah. Slow. What do I call it? Slow check type. All right. So this is obviously completely different from what we have down here, but I don't care. Different from what is below. All right. If okay, I have this nice little diagram that kind of shows me like how these travel. Basically, oh great, we're actually the little demo we had working last time isn't going to work either in this case. I guess we also need like a client wake up type, or that could be a special kind of response, because that's how we're going to initialize the clients. But again, we're not going to be able to test this for a while until I write all this out. And also there's a bunch of stuff that's not going to compile at all down here. Okay, if we have a server type, so it means we just got a packet into the server. Actually, I'm very glad for this diagram because it shows me exactly what I need to do. This is arrival. It's not even an arrival to server. It's just like something in the server. And we have 4 types. And these types are distinguished by the packet ID. So that's what's in params. And this is exactly why I changed this guy, free list, to have reserved IDs. So we're going to need some reserved IDs. Probably quite a few of them even. So first one is going to be, actually let's take the more general case. If params, so params is going to make this explicit. U64, include those. Include types.h U64. U64 packet ID is equal to params. That's exactly, it's the same thing, but whatever. If packet arrives to server, this is going to be the case where if packet ID is greater than max reserved ID -1. So I'll just type this out right here while it's all close together. But we're basically gonna have U32 hardware to software ID is equal to 0. We're going to have U32 software to execution ID is equal to 1. We're going to have U32 exec start ID is equal to 2. And we're going to have U32 exec start. The ordering of these actually matters for tiebreakers. Okay. You can already use the exec end ID, so kind of like a execution loop ends, and we're not going to reschedule immediately from the queue. We're going to wait for someone else to arrive and trigger the execution. But let's just say we're going to have a lot more of these than we're going to have of these. That's execution ID. The other one is going to be U32 exec to software ID is equal to 4, and then we're going to do U32 max reserved ID is equal to exec to SO ID. Okay, cool. And these are going to go to the top, and they're going to be uppercase. They're going to be uppercase. Let me just change to SO ID. SO to exec ID. So wait, what am I talking about here? So if it's greater than max reserved ID, this came from the client, and this needs to go into the server hardware queue. So this is going to be, we don't need to read the packet ID. This is going to have a lot of information in it, but basically we're going to do CB queue packet ID, HWQ packet ID. And this then schedules a server software arrival. So what we need to do is put a very no, we don't need to do any checks here. We're gonna do scheduler. Wait, how does this go? Well, fuck you. Cat includes scheduler. Schedule. We're gonna schedule into the main scheduler. Oh, what the hell are we gonna do here? Event is gonna be. Where's that damn code here? Let's do this. Socket delay and socket event. This is going to be socket delay. No, this is going to be U16, U30, U64. Hardware to SO delay is equal to, I don't know, that much? No idea. Delta is here, so H2 SA delay. And then we have, events. Socket type and tmask. No, this is going to be server type. Tmask, parambits, and params is not going to be params, it's going to be SW2 exec ID. Okay, cool. Let me just do this. U64. Alright. That looks pretty good. 64 temp. Okay, so we can schedule that, and then else. Maybe gonna continue. This is a for loop, right? Just return here, keep it simple. Oh no, whatever. Else if packet ID, if it's equal to. So now we have our like special event that actually does not rely on any packet ID or anything. And exec end ID. All right. I think a lot of these are going to be pretty similar, actually. In fact, I would say they are so similar that I don't know. Let's see what happens. So hardware to software ID. That means that at this point, packet has waited the necessary amount of time to go from hardware to software. As long as we don't sneak any packets into the hardware queue without anyone knowing, then this should be fine. Let's see. What do we want to do? A good thing we just added a circular buffer because we need it right now. And this one's probably the most interesting one. Oh wait, yeah, maybe. So we have a hardware to software ID. We need to do CBQ, or actually U32 packet ID. So the packet ID is now going to like maybe moving packet ID, moving packet, I don't know, is equal to CB the Q, CBDQ CB, or this is going to be hardware Q. So we'll pop it off the hardware queue. Yes, I know if handle zero case. Oh wait. Okay. Okay, let me just add this one really quickly. Of course it is. Where? Damn it! Who the fuck has it open, huh? What would this look like? What would this actually look like? Wait, it would. Wait a minute. Dequeuing increments. There's got to be an easier way to do this. Because start could get into the end. Oh, it's because we make end be 1 past the array, so yeah, whatever. We'll just reset it to the empty state. These damn pointers. Whatever. Okay, cool. But now we have. Stop doing that, would you? You're getting annoying. VI include CB. I wish I had more time, like just way more time. Okay. Okay. If CB is empty, HWQ weird, but we'll continue. And we have the moving packet, we pop it out of the HQQ, and then we put it onto the software packet, moving packet. So now you're on the, congrats, you're now on the software side. The only thing we need to do is fuck. Oh, wait a minute. This is important to know. If it's not empty, then we need to schedule a server execution start event. If not, we don't. Yeah. So all we need to do is these three again. There. We'll do. So think of this as like how long it takes to get from a queue in the software to the like execution function. And this is going to be, again, the server type, but the parameter is going to be exec start ID. All right, and then I'll do SF2 exec delay, and that should be good. The order of this doesn't really matter. This is like further out anyways. So okay, that's CBQ. Now if we actually get wait a fucking second. We don't need this one actually. I don't. Wait. We do need a software to execution delay, but we don't need a special ID for this. So I think something like that. Oh wait, no. Got rid of the wrong guy. Hold on. 1, 2, 3. Fuck. Start ID. Execution start. This actually only does one thing, and it's gonna be like server dot executing is equal to true 1. And then we schedule a maybe it's like super fast, like 10 nanoseconds. to handle an order. I don't know. We can just change these as I see fit. Exec time, and it's not gonna be start ID. It's gonna be end ID. End ID 5x. And this will schedule. This will kind of kick off the cycle. Exec end ID is what actually will do stuff. We'll just this. Oh right. If server executing is equal to 1, continue. We are mid loop. Okay. We're doing this. Okay. You're actually going to schedule the exact same thing, or potentially schedule the next thing. Now this end ID is what actually pops it from the queue. Wait, if we get a start ID, but let me do this. If it's executing, we do 1. If it's empty, really weird. This is going to be software queue. Okay. In this case, we're going to do the same thing. If the queue is empty, really weird. But otherwise, we're going to do U32 exec packet ID is equal to CB dec of the software queue. Okay. And then we're going to do something like packets exec packet ID, and we're going to execute actually modify the order book based on this. Okay, so we'll actually modify it. And then what are we going to do? If we pop, we popped it, but then it still could be empty, and that's a fine scenario. If it's empty, and the more important one, also schedule a bunch of client in events. And also, let me just throw this in real quick, which is also why we added a CB. If I'm just gonna do pseudocode. If need to convert stops, convert su convert holder dot queue converted converted packet IDs, and then schedule exec to SUID event. I'll come back to that later, probably way later. If CB is empty, then we can just finish execution. We'll do server executing is equal to 0. Else we can pop again, and actually no, we don't need a pop, we just reschedule. So we'll do this exact same thing, and we'll do that. Okay, and I think that should be good. Notice how we're not using any packet IDs, these are special values. Okay, exec to SWID is going to be something like I don't know, while packet not equal to sentinel null convert holder dot dq packet is equal to that, su q dot push packet. And do we need to reschedule anything? You need to do this exact same thing. If it's not empty, then we schedule a SW2 exec. So something like that. All right, I'm pretty happy with this. I'm gonna commit and save. Ooh, fuck off. It's a mess, but source cb get add include cb get commit added cb empty git add source main git commit absolutely will not compile, but got my server events where I want them. Cool. All right. I think I'm going to stop for now.